Hi everyone, welcome back to our algebra review camp. So today is our day 6 and we'll start talking about the exponents. Okay, so we know that exponent is an operation, and since this is our first day talking about the exponents, let me first give you the basic definition of the exponent. Okay, so what does that mean to say if I want to raise a number a to the power of n? Okay, what does this operation mean? So basically that means we have some a's and we try to multiply them. Okay, so we are multiplying these numbers again and again. So how many a's do we have? So according to the exponents here, we have m of a's. Okay, so essentially that just means that we have m of a's multiplying together. And now based on this definition, we do have some properties of the exponent. Okay, so the first one is the product rule. So suppose I have a to the power of m times a to the power of n. What is the result? So why don't we start from this definition? Okay, so from the first power, we know this one is just a times dot 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 times a. And then we have m of a's. Okay, so the first power is saying that we have m of a's. And then we are multiply this by another power. And for the second power, we have n of a's. Okay, so we see that we just have a bunch of a's multiplying together, and we first have m of a's, and then we have n of a's. So how many a's do we have in total? So we just have a times dot 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 times a. We have m plus n of a. Okay, so we see that if we have this product, then of course we can just write it as a power. So to write it as a power, we can write it as a to the power of n plus n. Okay, so this is how we got the result from this product rule. Okay, and now let's move on to the power rule. So again, the power rule is saying that if we first have a power and then we raise that to another power. Okay, so a first to the power of m and then to the power of n. What is the result? So why don't we still just look at the definition? Okay, times a. Okay, so we see that we just have n of these powers multiplying together, and then we have n of this power, right? And then from the previous rule, we know that the product rule can be written as a addition within the exponent. So we just have a to the power of m plus dot 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 plus n. And then how many m's do we have? How many m's do we have? We just have n of these m's, right? Because we have n of these powers. So the result will be a to the power of m times n. Okay, so this is how we can get this result from this property. Okay, so these two are just two of the most important properties of the exponents. And then also in day 7 and day 8, we'll talk more properties about the exponents. Okay, so let's look at the first question here. So for the first question, let's first calculate what is 2 to the power of 3. And we know that it's just 2 times 2 times 2, which equals to 8. Okay, and then we go to the 2 to the power of 5, which we know is just 2 multiplied by the 8 and then multiplied by another 2. So the result will be 32. Okay, and of course, what is the product of 2 to the power of 3 and then 2 to the power of 5? So we can either use the 8 multiplied by 32, and this one will give us a 256. Or we can also try to use the product rule to write it as 2 to the power of 3 plus 5, which equals to 2 to the power of 8, and that will give us the same result. Okay, so we can either just use the 8 times 32 to give us the result, or just use the 2 to the power of 8. Okay, now again, let's also look at the second one. Okay, so for the second question here, 3 to the power of 2, that equals to 9, and then 9 to the power of 2 equals to 81. Okay, so what is 3 to the power of 2 and then to the power of 2? Of course, we can first find out the result from these parentheses, which give us a 9 to the power of 2. And then from the second question, we know this one just equal to 81, right? So this one equal to 81. Or we can try to use the power rule. So this one is also equal to 3 to the power of 4, which is also equal to 81. Okay, so we do have 2 ways to solve that. And then let's also look at the first question in the problem 3. Okay, because we see that the base number here is a negative number. So if we have a negative sign inside the parentheses, make sure that we first determine the sign. if the exponent is an even number, then the final result is a positive number. If the exponent is an odd number, then the final result will be negative. Okay. So here, because the exponent is an even number, so this one is equal to 6 to the power of 2. We can just remove the negative sign. And then this will equal to 36. Okay, so 36 will be the final result. All right, so this is just an illustration on how we can use these properties. And I will just leave the rest of the questions for you to solve them. Okay, so let's try to solve the questions, and then you can